Today's daily code problem of the day is count ways to build good strings number 2466. For this problem, we're given the integers 0, 1, low, and high. 0 and 1 being variables. We can construct a string by starting with an empty string, and then at each step perform either one of the following. We can append the character 0, the variable 0 amount of times, or append the character 1, variable 1 amount of times. This can be performed any number of times. A good string is a string constructed by the above process having a length between the low and the high inclusive. We want to return the number of different good strings that can be constructed satisfying these properties. Since the answer can be very large, we want to return it in the modulus of 10 to the 9th plus 7. That way we can return it as an integer. So if we look here at example 1, we can see that if our low is 3, our high is 3, and our 0 is equal to 1, and our 1 is equal to 1, that means we can apply a 0 character once and a 1 character once as well. And then we can apply a 0 character once, and that will equal our low of 3 and our high of 3. We can see that actually down here. So 0, 1, 1 is possible, where we have the string 0, then string 0, 1, then string 0, 1, 1. All binary strings from 0, 0 to 1, 1, 1 will be good strings for this. If we look here at example 2, we have lows equal to 2, highs equal to 3. So all good strings would be anywhere from 0, 0 and all the way up to 0, 1, 1 or 1, 1, 1. Actually, but we can't do 3 ones in a row since it's of length 2, so 0, 1, 1 is the highest we can go. So let's go ahead and dive into this problem. So at first glance, the problem might seem a little bit hard, but if we think about it, it boils down to just simply counting the paths to reach a specific string length. The key idea is we can use dynamic programming to calculate the number of ways we could build strings up to a specific length of high. So we'll use our dynamic programming array, where the dp of I will represent the number of ways to build a string of length I. So we'll have an array. It's going to be a integer array, so int dp, right? And sorry, that is going to be equal to a new integer array, and our dp of I is going to be equal to our basically we'll see the number of ways to get an ith length. So let's say we could get 5 strings of length 3 in some way or form using our zeros and ones. Then we would have dp of I, whatever length I is equal to 5. So as we calculate that, we can then keep track of it and see if it falls between our low and high. So let's lay out our plan. The first thing we're going to do is initialize our dynamic programming array. We'll then iterate our dynamic programming calculations. We could then find our result calculations. So those that are strictly between our low and high. And then we simply need to modulo our operation so it fits within the size of an integer. So let's look at the code now. So the first thing we could do is define a global variable that we'll call our mod. So we're going to have a private integer called mod, and that will simply be equal to the integer version of 1e9, or 10 to the power of 9 plus 7. And the reason we want to define that is so we can simply mod later on without having to type all that bullshit out. So let's go ahead and jump into the code. So the first thing we want to identify is if our 0 block is larger, we want to swap the things to keep them consistent. So if our 0 is greater than our 1, if our 0 is greater than our 1, we can return the count good strings of low, high, 1, 0. So that's efficiently switching our 1 and our 0. So that way we can solve it one way, automatically using the zeros first and the 1 second, because we're assuming that the 1s are bigger than the zeros. And if we do happen to have the situation where the zeros are bigger than the 1s, we'll simply swap them, and it'll run the same exact function, just with the swapped variables. This will make it easier for us to run our calculations. We can then initialize our array. So we're going to have an integer array called dp, and it's a new integer array, and it's going to be of length high plus 1. So that'll allow us to keep track of all of our variables. And then we'll also have our integer result, which is going to let us count how many results we have. Then we can initialize our base case. So our base case is one way to build a string of length 0, would just be a 0. So dp of 0 is going to be equal to 1, because there's only one way to build a string of length 0. So finally, we can then iterate our dynamic programming calculations. So we'll calculate the number of ways for each length. So for each integer I, we'll start at 1, since we already initialized our base case of 0. As long as I is less than or equal to our high value, I will increment. Then we're going to simply check. If our I is greater than our 0, we can add it. If our I is greater than or equal to our 1, we can add it. And if I is greater than or equal to our low, we should update our result. So we'll take a look at each of these. So if I is greater than or equal to 0, then our dp of I should be updated to be equal to our dp of I, whatever the current value is, plus the dp of I minus 0. So however many values are within 0, and then we can modulus mod. This is simply, we add ways from a block of size 0. So of a block of size 0, and that's how many we add. So we add a total amount of ways from a block size 0. So if our block is currently of length 0, let's say length 0 is 1, we're going to add how many more ways that we can get to 3. And then we could do the same thing with our 1 value. So if I is greater than or equal to 1, then our dp of I will be equal to dp of I plus our dp of I minus our 1 value. And then we'll mod. This adds ways from a size of block of 1. And then we could do the same thing for our low, except we're going to update our result. So if I is greater than or equal to our low value, that means it's within a valid range. Our results will be equal to the result plus however many results we find in dynamic programming of I. And then we will, once again, modulus mod. So that's adding the valid lengths to our result. And then we could simply return our result, which has already had the modulus applied to it. So if we run this, passes our test cases, and if we submit it, passes all solutions. Thank you, and follow for more daily LeetCode solutions.